Yeah, good afternoon, everyone. In yesterday class, we have discussed about data dictionary, and types of data dictionary we have discussed, which are under the storage access. Now, in this chapter, we have discussed what is data dictionary and what is the types of data dictionaries. There are two types of data dictionary we have discussed. One is active data dictionary, one is passive data dictionary. And And again, we have discussed about three types of use of the data dictionary. They are, user level and all, then DBA level. These are the three types of use we have discussed under the data dictionary. And the next one is, we also even discussed about what are the advantages of data dictionary and what are the disadvantages of data dictionary. And next one, we have discussed even about the indexing methods and various types of indexing methods we have discussed in yesterday class. These are the types of indexing methods. These are now see there are ordered indices, then primary index, and clustering index, secondary index. Under the primary index, you can see there are dense index and sparse index. These are the types of indexing methods. Okay, types of indexing methods. Now, under this, we have discussed the what is ordered indices. What is ordered indices? We have discussed, and we have discussed even about the primary index. Primary index, we have discussed the indexing method. The next one we will see the dense index. Next one, see dense index. Okay, dense index. Now, what is the basically we have seen the what is the index means. They one the key is developed to identify to easily search the content, okay, using the key. So that is the indexing key we can say. When the dense index, which contains the and record for every search key value. So in the data file, so in the dense index, there is a record, index record for every search key value, okay, in the data file. So that means that with that search key, the data access is more faster. The data access is more faster. Example, in the similar, the number of records in the index table, which is same as the number of records in the main table. That point we understood in the beginning level. So in the database table and the index record, they contain similar records. Okay, the similar records it contains. Example, you see, these are the indexing keys are there. This is the relevant data to the index. If we go down, see, it needs more space to store index record itself. The index records have the search key and a pointer to the actual record on the disk. So this is the index key and which is pointing actual record in the data dictionary, the disk. Okay. This is the indexing key. With this key, you can identify the record in the disk. Okay. So see, What is sparse index? What is sparse index? Now, in this method, when the size of the table grows, that means that suppose this is the table, because the table contains, let us say, 2 rows and 3 columns. That is 2 by 2 rows, 3 columns. In the sparse indexing method, the table size grows. That means if the table of the size grows means what? Let us say from 2 by 3 to, suppose if it increase to 3 by 3, 3 by 3 rows, 3 columns. Okay, in that case, I'm talking about the size of the mapping also can be increased. Okay, mapping means the key and with the actual data. The key and actual data. So obviously, when the size of the table increases, the mapping also will increase. So that is a basic point. So these mappings are usually, these mappings which are usually kept in the primary memory. Okay, this mapping. That means that your mapping done with the key value pair. Okay, key value pair. This is the mapping. So that means example is, so one is mapping with the, suppose A, and this is B. That means one is mapping to this value and two is mapping to this value. Okay. So where this data will store these mappings, where these mappings will store its key value pairs in the primary memory, in the primary memory. So that address fetch should be very faster. So when it stores in the primary memory, when it stores in the primary memory, so fetching the address is very faster. Means if I want to this element address, I can access very fast. Okay, that is the advantage. Next, then the secondary memory searches the actual data based on the address. Okay, the primary memory, the address will store. The secondary memory, the actual data will store. So based on the primary memory given address, this primary memory given address, based on this, the secondary memory searches the actual data. Okay, so that is based on the actual address which you got from the mappings. Okay, example, this is the mappings. This is a mapping table. This mapping table stored in the primary memory. Okay, in the primary memory, and actual data stores in where? In the secondary memory. Okay, secondary memory. Okay, so when the primary memory given address, the primary memory which gives what address it will give address. By taking this address, so what it does, it will search in the secondary memory. So very faster. Okay, based on the primary memory given address, it will search in the secondary memory very faster. That is the map. That is the main thing. If the mapping size grows, as we discussed in the earlier case, if the mapping size grows, then fetching the address itself becomes very slower. Okay. So obviously, when the mapping grows, then the fetching will become very slower. When more mappings are there, when more mappings are there, it will take time to fetch the data. Example, one is mapped to A, Let us say 2 is mapped to B. Okay. And this is containing address. Okay. Address. Now, based on this address, it will search in the secondary memory. Okay. Secondary memory. If these two mappings are there, fetching the data from the secondary memory is very fast. If these mappings are keep on increasing like this, so on up to, let us say, 1,000. Okay. If these mappings are becoming more, then fetching the data from the secondary memory also will be very less. It will decrease the performance of the secondary. I mean, that's the only point is. If the mapping size grows, then fetching the address itself becomes very slow. So in this case, what will happen? The sparse index will not be efficient. Okay, sparse index will not be efficient. To overcome this, the secondary index is introduced. One more index is introduced. Understood what is sparse index? When the mappings are very less, when the mappings are very less, then the primary memory given address, the primary memory given address, based on that, searching actual data in the secondary memory is easy. Okay, that means very faster, means very faster. But when the mappings are becoming more and more, the mappings are more, then getting address is little slower. Getting address is little slower. So based on that, obviously we cannot fetch the data very faster from the secondary memory. Okay. Because of this problem, one more indexing method is introduced. That is called secondary indexing is introduced. That is the drawback of the sparse index. Yeah. The next more index you see clustering index. One more index. Just look at just read clustering index. Clustering index. Okay. The clustered index can be defined as an ordered data file. Okay. The clustered index is indexing. The clustered index can be defined as an ordered data file. Okay. Sometimes the index is created on non-primary key column, which may not be unique for each record. The clustered index can be defined as an ordered data file. Ordered data file. You can see here. Ordered data file. And sometimes the index is created on non-primary key columns. So what is primary key column? What is non-primary key column? The difference is primary key column we have discussed. So this is the column C1. This is the column C2. This is the column C3. Now let us say this is the serial number. Now serial number we made it is a primary key. Okay. That means that the serial number is always unique. You can say this is 1, this is 2. Okay, likewise, it is always unique. So when it is a unique, that is called primary. And other columns, let's say this is a one more column. This is one more column. These are two columns are non-primary keys. These two columns are non-primary keys. Non-primary keys. Okay. So what is clustered index is talking about? Sometimes the index is created on non-primary key column. So what is taking sometimes this indexing is also created using these non-primary key columns. Okay. So that means that may not be unique for each record. So if we take the non-primary key column, it means that each record, this is one record, this is one record. Each record may not be unique. Okay, it is may not be unique. Why means that can be there is a chance to enter the duplicate data. There is chance to enter duplicate data. So that is the meaning. So this what will happen here in this case to identify the record faster. So identify the record faster. So what we are doing, we are grouping two or more columns to get the unique value and get the index out of them. So as these records are not unique, so what we are doing to create a cluster index column, cluster index to create index. Okay, we are considering not only one column, we are considering two more columns, two or three columns likewise. Okay, two or more columns. We are grouping. That means along with primary key, along with primary key, along with primary key, we are grouping, we are grouping two more columns. We are grouping two or three columns. We are grouping two or three columns. Yeah, to make a unique index, to make a unique index, so we are grouping non-primary columns. We are grouping two or more non-primary columns to make a unique index. To make a unique index. Okay. That is the meaning of this. Now, this method is called clustering index. This method is called what? Clustering index. If there is a table, there is a table. This table is having, let us say, one, two, three, one, two, three, four columns, one, two, three rows. Okay, this is a now these are the column numbers. Let us say serial number and let us say pass. This is 12 and this is grade. Now this serial number is a primary key. It's a primary key, and these are non-primary keys. This is primary keys. Now to make cluster index, to make a cluster index, so we are grouping what? We are grouping two or more non-primary columns. We are grouping two or more non-primary columns to get the record very faster. To get the record very faster. If we don't group these non-primary columns, there is a chance to get duplicate record. Means we cannot get a unique record. So that is the cluster index method is all about. Now see, there's an example here. Can you see? For the sparse index alternative is, for the sparse index alternative is, the secondary index is introduced. For the sparse index, alternative is secondary index is introduced. You can see secondary index here. This is a secondary index. The secondary index. Now, what is happening in the secondary index is the secondary indexing to reduce the size of mapping. To reduce the size of mapping, another level of indexing is introduced. So we said what in the sparse index, the mappings are, when the mappings are increased, okay, so getting the address is a little slower so that we cannot search the record in the secondary memory. So due to that problem, we have introduced the secondary index method. In the secondary index method, this method is to reduce the size of the mapping. So another level of indexing is introduced. Okay. So what is happening in this method? The use range for the columns is selected initially so that the mapping size of the first level becomes very small. Okay. Then each range is further divided into smaller ranges. Okay. The mapping of the first level is stored in the primary memory, so that address fetch is very fast. Okay. And the mapping of the second level is an actual data stored in the secondary memory, that is in the hard disk. Okay. So where the first level mapping is storing in the primary memory. So with that mapping, what is happening? We are getting the address very faster. That means fetching the address is very faster. And the next level of mappings are where they are storing in the hard disk, they are storing. So that with that mapping of the second level and the actual data, both are storing at the secondary memory, that is in the hard disk. Okay. Now see, this is the primary memory. Okay. Now this is the secondary memory. This is the secondary memory. Now this is the data. This roll number. This is the column, and which is pointing to the next in the memory, secondary memory. Okay. So secondary index. Now next one we'll see what is bitmap index. Bitmap indexing. Which bitmap indexing is a special type of database indexing that uses bitmaps. That uses bitmaps. Now, this technique is used for huge databases. Okay, bitmap indexing is what is a special type of database. It is a special type of database indexing which uses bitmaps. Okay, this technique is used for huge databases. Okay, the database is more and more. Okay, not for limited records. It is used for more records. If the database contain more records. Okay. Okay. For that, this bitmap is used. So where column is low cardinality, and these columns are most frequently used in the file. Okay. That is the purpose. And why we need bitmap indexing? This bitmap indexing is very clear through the, well discussed with the example. Yeah. Yeah. This is a need for bitmap indexing. So example here is see, suppose a company holds employee table with attributes like employee number, employee name, job, or new employee and salary. So these columns, these components. Okay. I'll take the example. So let's assume that the employee are hired once in a year. Okay. Employee are hired once in a year. Therefore, the table will be updated very less and which remaining static most of the time. That means which is fixed. Static here means fixed in most of the time. But the columns will be frequently used in queries to retrieve data. Okay. What is the kind of data? Suppose the number of female employees in the company, etc. Okay, this kind of data will be frequently accessed. In this case, what will happen? We need a file organization method. Okay, we need a file organization method which would be very fast enough to give quick results. Okay, but any of traditional file organization method is not the fast. So therefore, we switch to better method storing retrieving data known as bitmapping index. So alternatively, what we are going for this? So alternatively, the file organization method is a little slower. Okay, that is not very fast. So for that, we are going for bitmap indexing. Okay, we're going for bitmap indexing. Now see here how bitmap indexing is used. Now take this table. Take this table, we will understand. Yeah, take this table. Yeah, take this table. See here. Now this example, if you see, actually what is a bit here? Bit is a basic unit of information. Basic unit of information. It is used in the computing. Okay, used in the computing that can have only one of two values. Okay, that is say 0 or 1. This is called bit. This is called bit. Okay. The two values of the binary digit, okay, which also can be represented to the true and false. That is true and false, or we can say yes or no.
Okay. So in bitmap indexing, what is happening? These bits are used to represent the unique value in those low cardinality columns. Okay, low cardinality columns. Now, this is a technique of storing low cardinality rows in form of bits are called bitmap indices. Bitmap indices. Okay, you can see here we are storing yes or no, yes or no in this bitmap. You see here. Now here bitmap index yes as value from this value and row 1 and row 4 was value yes in the new employee column. Okay. Now in this case, there are two such bitmaps are there. Okay. One is new employee, which is yes, and for new employee, which is no. Now it's easy to see that each bit in bitmap indices show that the particular row refer to a person who is new to the company or not. Okay. So that is the here bitmapping is. The advantage is efficiency in terms of insertion, deletion, updation. Okay. So if you take a efficiency wise, the insertion and deletion updation is uh, efficient. And we can also have the faster retrieval of the records. These are the two advantages. And if you take a disadvantages, only suitable for it is suitable for large tables. Please. Now bitmap indexing is time consuming. One is it is suitable for only for large tables. Another point is it is time consuming process. Okay. Next one is the domain indexing. Next one is domain indexing. Now this domain indexing is created by the user for the application specific domain. Okay. For the application specific domain. So they need not be actual index and they can exist in the then it can exist in the database or in the form of file. Now, for example, some documents that are used in the application, pictures, videos used in the application. Okay. These are some examples for domain indexing. Example for domain indexing. The next one is function-based indexing, and you can see virtual indexing. Now, what is the function-based indexing you see? Now, this type of indexing will be created on columns of tables. The function-based indexing can be created on the columns. And thereafter, applying some functions on those columns. Okay. And some function which are frequently used are, you can see these are the type of some functions we can frequently use upper, lower, truncate. Okay. These indexes are created because if you have index only on the column, the query with this column has some functions on it. Okay. Now then the index will not be used. Index will not be used. This is a function-based indexing. Next one, see virtual indexing. Virtual indexing. See, virtual index is it creating new index columns for the lot of the resource. But the actual behavior of the index will be known only after it is created. Okay. So when the virtual indexing will be actually it will when it will be used means when it is created, then only the actual behavior can be come to know that. about the virtual index. But when the developer and testers are checking for the performance issues, they cannot afford for creating and deleting the index each time. Okay. And so virtual indexing are created, which are not really created, but it will affect the query plans and performance to show ups. Okay. If it is present in the database. Okay. So that is the to reduce the resource consumption and boost the performance at test. This virtual index works as required, but then a real index is created later. Okay. So everything they will test on the virtual index. Once it is confirmed that it is working, then they will create the real index out of that result. So this is the virtual index. Next one we'll see. Yes, database transactions we have completed. Database transactions we have seen the SQL actually. See, but little see once again we'll see what is the transaction properties. What are the transaction properties we'll see. See here that there are four types of properties are there. Four types of properties are there. So one is atomicity and consistency and isolation and durability. These are the some of the properties of the transactions. We can say in shortcut we call it as acid properties of the transactions. Now this property states that each transaction must be considered as a single unit and must be completed fully or not completed at all. So what is atomicity is talking about means if a transaction is started, it must and should be completed. Otherwise, it should not even start. That is a that is the nature of the atomicity property. So that is the talking. No transaction in the database left half completed. Okay. So when the transaction is started, either it should be completed completely or else not even started it. So in the middle of the transaction, it won't break. So no transaction in the database is left off completed. So that means the database should be in a state either before the transaction execution or after the transaction execution. It should not be in a state of executing. Okay. So that means it is in simple words, we can understand that it is a pass or fail. That's it. It's not in the middle that okay, it is going to pass or going to fail. It is complete transaction. It is complete transaction. Now, an example you can see that. See ATM example if you take, if the transaction fails after, then the user will get money. Okay, but his account will not be updated. So this will not happen. So whenever transaction is executed, all the steps in should be completed or not completed at all. Okay. Suppose ATM withdrawal has money single steps in it, all should be executed as if they are part of the single transaction complete. Okay. Now the state of the database should be either before ATM withdrawal or after ATM withdrawal. So this will make the system in consistent state and will not be any incorrect data in the database. So that is what about the atomicity. So atomicity is talking about either a transaction is completely complete or else it is completely not started. Okay. In the middle of the transaction, it won't
take any kind of pauses. That is called atomicity. Now, whereas see the consistency is here. So any transaction should not inject, okay, should not inject any incorrect or unwanted data into the database. So it should maintain the consistency of the database. Should maintain the consistency of the database. Now, you know, for example, after total marks, while calculating the total, now it should not perform any other action like inserting or updating or delete. Okay. It should also not to pick marks for other students. It should be it should be picking the marks for the same student and calculating the total. So and it maintains the consistency of the database. Okay. So in the ATM withdrawal example, if you take, now it should make sure that withdrawal amount is 500 and deducted amount from the account is also 500. It should not give 500 to the user and deduct 100 from his account. Okay, it should always make sure system is well balanced before and after the transaction. Now there should not be any mistakes in database because of the transaction. One of the methods to achieve consistency of the database is to define primary and foreign keys. So how we can achieve the database consistency means by using the primary and foreign keys. Now these keys will not restrict unwanted data insertion, deletion, or updation. Okay. Now this primary key and foreign key, they won't allow these they won't allow these to the so these keys that means primary and foreign keys, they won't allow any kind of unwanted data, any kind of unwanted data that is which is insertion, deletion, updation. These kind of modifications they won't allow. Okay, by checking the integrity of the data in the DB. Suppose the transaction was to delete the department for which employees are still working, then the system will not allow deleting the department unless all its employees are deleted from the system. Okay, this is because the foreign key is defined on employee table for its department. So that means if the dependency is there, it will not delete immediately. Once after deleting all the members in the department, then only it will delete the record. So another way of is maintaining the consistency is log for each transaction. It will make sure if there is any failure in middle of any transaction, the data will be recovered by seeing the log. Now the system fails after step 2, an ATM withdrawal. The system should have kept the log of transaction before executing it and after executing. So when system recovers, it sees that log. The log is one file to contain the history of the transaction. For last executed transaction and understand the system which has not been updated for the amount withdrawn and updates it. Okay, this is the consistency. Now see the isolation. Now what is the isolation you see? There are multiple transactions executing simultaneously. That is, this is a transaction A,
This is transaction B. This is transaction C. These multiple transactions are executing simultaneously. Then all the transactions should be proceed as if they're single transactions. These all should proceed that as they are single transaction. Okay. But individual transactions in it should not alter or affect the other transaction. Okay. So that means each transaction should be executed as if they are independent. Okay. This is isolation. Example, you see, suppose there are two transactions are there, updating the Tom's address and the James phone number, so which are executed in parallel. Now each transaction should be executed in its executed own to complete their transaction and should not affect the execution of other transaction. Okay. And similarly, in money withdrawal from ATM, if manager checks his account balance while he is withdrawing the money, the manager should see the balance either before withdrawing the money or after withdrawing the money. Okay. The manager viewing his balance is considered as a another transaction. And a user transaction should not give inconsistent data to manager's transaction. Okay. The manager should not be able to see the amount after step two. Okay. The manager should see the balance only after it is updated in the database. Okay. Now this will make sure that each individual transaction is completed and any other dependent transaction will get the consistent data out of it. Any failure to any transaction will not affect the other transaction in this case. This is the isolation. Next one is durability. Next one is durability. Now see what is the durability here. The database should be strong enough to handle any system failure. Okay. If anything is the database should be strong enough to handle any system failure. That means if any failure is there, the database should not uh, change its nature. Okay, it should not happen to anything to database. Should not be working for a single transaction alone. Okay, it should be able to handle multiple transactions too. Now, this database must be in a position to handle multiple transactions. To handle multiple transactions. Okay, it should not be able to handle only one transaction. Should not be able to handle only one transaction. It should handle multiple transactions. That is transaction A, then transaction B. This is transaction C. The multiple transaction it has to handle. Now, if there's any set of insertion, updation, then it should be able to handle and commit to the database. Okay. Now, if there is any failure, the database should be able to recover it to the consistent state. So that is the durability here. That is the durability.
Suppose the system crashes after the transaction updates some user address, but before committing the transaction to the database, the database should be strong enough to recover user address, user's original address. So that is the durability here. Suppose in an ATM withdrawal example, if you take the system failure happens after some 2 stages, the system should be strong enough to update the database with its new balance. After the system recovers, it should keep a log of each transaction and its failure. So when the system recovers, it should be able to know when the system has failed, and if there is any pending transaction, then it should be updated to the database. Now, these are the properties of the transactions. These are the properties of the transaction: atomicity, durability, isolation, and consistency. Now, see next one. What are the transaction states? There are the transaction states contain 5 states. Then is one is active state, and one is a partially committed state, then committed state, failed state, and aborted state. These are the type of substates the transaction contains. These are the types of states. You can see one is active state, one is partially committed states, next one failed state, then aborted state, so one committed, then next one is antithesis. Okay. Now see one by one it is. Now what is the active state here? Now this is the first state of the transaction. Is the first state of the transaction, and if the transaction is being executed, okay. Example, updating, inserting, deleting a record is done here. Okay. But it's still not saved to the database. So when we say transaction is, it will have set of small steps, and those steps will be executed here. This is called active state. Okay. Now, what is partially committed state? Now, partially committed state is also an execution phase of the transaction. Here, last step of transaction is executed, but data is still not saved to the database. But in our example, it is calculating total marks, final display. The total mark step is executed in this state. So this is partially committed. What is the committed state here? In the committed state, that all the transactions are permanently saved to the database. Which are permanently saved to the database. That means if the transaction A completes it all transactions, it will commit, it will commit, it will commit to the database permanently. It will commit to the database permanently. Now, which is the last step of the transaction? Okay. So without any fail, it will commit, it will permanently store into the database. That is the committed state of the transaction. What is the failed state here? So if a transaction cannot proceed to the execution state, okay, now then the transaction is said to be in failed state. If any transaction, now we said 5 states are there, 1, 3, 4. Okay. Suppose if any transactions cannot able to proceed for the execution, okay, then that type of transaction is called failed transaction. That is called failed state, we can call failed transaction, we can call. Example here, in the total marks calculation example, if you say the database is not able to fire a query to fetch the marks.
Database is there. This is a database. To this database, we have given a query. We have given a query. The query job is to fetch the data, but this query is not able to complete, that is not able to fetch the data from the database. Now this is called a failure transaction. Now very first step of transaction, so when it the transaction will fail to exit. So this is called failed transaction. That means if the query is not able to get the data from the database, that is called failure transaction. Next one, the aborted transaction is, now if a transaction is failed to execute, in a similar way, the above case, then the database recovery system will make sure that the database is in the previous consistent state. So there is a one more system is the database recovery system. This system will take care of to get to the previous state of the transaction. If it not if not brings if not brings to consistent state, see, yeah, if not brings the database to consistent state by aborting or roll back the transaction. So we can roll back the transaction or we can abort the transaction. Now if the transaction fails in the middle of the transaction, now all the executed transactions are rolled back. Okay. See, if any transaction, if you say transaction A, if any transaction in the middle it is a failed, this transaction we can roll back. This is called rollback. We can roll back this transaction, okay, to its consistent state before executing the transaction. So wherever it is started, from which stage it is started, to that stage, we can roll back the transaction. Okay, we can roll back the transaction. So once the transaction is aborted, it is either restarted to execute again or fully it is a failed. It is fully killed by the DBMS database. So if any transaction is it is aborted, that is it is either restart from the beginning, that restart from the first stage onwards, or else it is completely kill the transaction by the DBMS. So this is called aborted stage. So these are the five stages of the transactions. These are the five stages of the transaction. Now we have discussed about the stages of transaction, then the transaction properties, asset properties. We have discussed the asset properties. The next one discussed about the indexing methods. What are the indexing methods, advantages and disadvantages? Advantages, disadvantages we have discussed. So next we will see what is the concurrent execution and recoverability of the transaction. What is the concurrent execution and recoverability of the transaction? Now see, now these are the some examples of the concurrent execution. Now, these things we will discuss in the next class. What is concurrent execution? What is the recoverability? These things we will understand in the next class.